Hello ladies and gentle ladies, welcome back to another railroad development stream. My camera is not in the right place. Is it? Maybe it is. Bit off. But hello, welcome. So it has been a week, I suppose. It feels like it's been a lot longer for me. Because I haven't done any sort of streaming or editing or anything in the past week. And we didn't stream yesterday, so it feels like it's been a lot longer for me. But regardless, today we're going to be continuing work on the SST, of course, so the semantic syntax tree, and more specifically on inspections, which is what we've been doing last time. Actually, last time specifically, we started work on the project model. Not that. Did we not call it the project model? I thought we did. Well, we started work on the project model anyways for the SST. Let's see if I can actually find that real quick. It's in here, project. We started on, I think, the where is it? It's not, was it this? It might have been this. We were doing this, I believe. So basically the point of this was to extract things for a specific project. So we would index an entire project, for example. This isn't the files I was looking, this is the file I was looking for. There you go. So this is what we were working on last time. Now I have all of that done now, so we can now technically index an entire project, and that is technically done. Like it does already do that. It doesn't do it in the background though, so it kind of works, kind of doesn't. Regardless, that's pretty close. So what I've been doing in the meantime is I've been getting codecs to generate me this absolute whopper of a file, and basically this is everything we need to do regarding the inspections for the SST. As you can see, there's a lot, and I've got it to categorize kind of difficulty in here as well. So we've got like starter stuff, which literally anyone could do. We have easy stuff, which once again pretty much anyone could do. It might just take a little bit longer. We have medium stuff, which you would need to have some Java experience, some like fair amount of Java experience to do, and then we have hard stuff, which you'd need to be pretty good at Java to do, and also more specifically understand kind of how Java works when you get to that hard level. So actually the majority of these are easy. Like if you go through here, you'll see there's a lot of starter ones, there's a lot of easy ones, and there's quite a lot of medium ones. There aren't that many hard ones. So in theory, if it's not just me working on this, this could be done in maybe a month's time, which would mean we have basically an entire Java, like Java will just be, I don't want to say done, because it won't be done, but it will be like pretty much there. So I mean, you can see the ones here that I've already done. So these are basically the ones that are already implemented, which is just all of these ones. And then it's split up into categories. So we have things like abstraction. So you have here, for example, instance check for this. So you just detect if it's doing this is instance of something. Obviously a very silly thing to do. So you provide a warning for that, right? You have like optional used as a field of parameter type, because that's not really meant to be used for that, because stupid. So you got that as a warning. Got public method not exposed in interfaces. All of these ones, I mean, none of these are hard. Like this one is the only hard one. Actually, this one is a hard one as well. So there's find codes that manipulates another object's data instead of its own. Which, you know, I think IntelliJ has that off by default. I'm actually not sure. And there are these two as well. Static member only used from one other class, right? Yeah, so I mean this is hard because we don't currently have any way to detect usages, but that's obviously something we're going to need to implement soon, because that's important. Hello, Suryansh Anand. I probably butchered that. Welcome to the stream. And we also have type may be weakened. I don't know what that means. Replace concrete or overly specific types with weak abstractions where valid. I don't know how the hell that would be done. Like, some of these, as I say, are really hard, but the majority of them are easy. Like, if you look at a starter one, for example, say this one, multiple top level classes in a single file. That is easy peasy. I promise you anyone could do that. It's literally like 2 lines of code. Or for example, utility class is not final. That wouldn't be too hard either. That's why it's marked as easy, because all you have to do here basically is check, okay, is the class final? Does the class just have static contents? If it just has static contents, then you flag this warning, right? That's basically it. Oh no, if it's not marked as final, yeah, if it's not marked as final and it only has static members, then you flag that warning. So that's pretty easy. If we look at a medium, you have like utility class can be enum. Now that's pretty hard to do, but not like super hard to do. So you have to detect, does it just have like static constants? And if it does, then it can probably be an enum. Kind of just that kind of thing. There's loads of starter ones, as I say, like double negation, right? For example, doing not expression. Easy peasy lemon squeezy. You just look for 2 exclamation marks in a row. That is it. So as I say, if any of you guys want to help with Railroad, this is your opportunity, because a lot of these are very easy to do, and they are important, to say the least. So just let me know if, well, I guess you don't technically have to let me know, but join the Discord, which is linked in the description, and come to the Railroad channels and just put it in there, and we can kind of work on that. Regardless, today we are actually going to do some of these, but we're going to try and do some medium ones today. I think is probably a good way to go, because I don't want to steal all the easy and starter ones from anyone who wants to do them. So we're going to try and find some medium ones. I don't have any plans for what medium ones, so we'll just go top to bottom and see what we have. Okay, like we have something like this, like we can look through the hard ones as well, because some of them are hard, but like not super hard. So the hard one here, public method not exposed in interface. Find public class methods that are not represented in an interface contract. Right. That's the other thing I should say, by the way, is that some of these are just like for detecting things. They're not actually for like emitting warnings or emitting errors. They're just like detecting that this is a thing. At least as far as I'm aware. I don't think this should be a warning at any point. That would probably wouldn't be too hard. The only hard thing about that is you have to detect if 2 methods are the same, which isn't easy as it's not as easy as it sounds. So I think let's go down to the medium and have a look what it says here. Interface method clashes with method in object. Detect methods that conflict with object. Okay, that wouldn't be too hard to do, I don't think. Object protocol expectation. Okay, let me just ask Codex, since Codex wrote this, like what exactly this requires. And then maybe we'll do this one. Okay. Here's what I've given it, by the way, guys. So we're just going to see what it says, and we'll see if this is a viable one to do or not. It may not be. If not, let's see what the next ones are. So we have this one, overly strong typecast. Detects cast stronger than necessary for the operations performed. Yeah, I don't really know what that one means. Like, I don't know. Oh, okay, I see. That would be quite hard to do, I think. Because we'd have to check the entire, like, inheritance line. I don't think we can do that yet. We don't have any inheritance. Let's check. Is inheritance, because I think that's in here somewhere. Inheritance issues, here you go. Yeah, we don't have, we have this one, but like that is it. So that would be pretty hard to do. Okay, that's still looking. Let's see what the next one was. I don't think that one was inheritance. Private method only used from inner class. Private helpers that are effectively scoped for inner type use only. Yeah, I see why these are medium. Like, it makes sense because that's not like hard, but it's just kind of like annoying. We have two hard ones here as well, but we already looked at these ones, right? So static member you only used from one other class. I feel like that one wouldn't necessarily be so hard, but once again, it's just like finding usages, which we don't have. Type may be weakened. I feel like that's very similar to where is it? Overly strong typecast. Like similar. Not the same, but similar. Oh, what's it said? Here we go. So, okay, it's given us a whole essay. We're gonna have to read this then. Okay, so this one is narrow and title. In Java is mainly about clone and finalize declared in interfaces because those collide with objects protected methods in ways that can make the interface impossible for a normal class to implement. Makes sense. This item inspection is a very specific edge case, not all object method. What it means in Java, every interface method is implicitly public, but object has two relevant zero-arg methods that are protected. I see. Right. That makes sense. Okay. Yeah. So you have clone and then you have finalize. If an interface declares a method like clone, a normal class cannot implement it. The class would only need one method that that satisfies the interface's public double and overrides clone. That's impossible because clone, cannot change from object to a double. Inspection is meant to catch interface declarations, use clone or something. Okay, so I mean, really, what we're just looking for then is looking for a method with the name clone or finalize that has no parameters. I don't think we care about the return type in this case, because if the name matches and it doesn't have any parameters, then it doesn't matter what the return type is because they're the same method. Like, you can't have an object clone with no parameters and a double clone with no parameters. You just can't do that. So I think that's all we need to do. So I don't think this one should be too hard. Means you'd likely not need major adder. Just put it alongside the inheritance checks or as a small new provider. Yeah, we'll make it a new rule. We don't want it to like be integrated. Yeah, so create a new entry. Blah blah blah. Oh, that is the thing. Okay. Yeah, so if it does return objects, then it's fine. Like, it's weird, but it's fine. Like, that's not a problem. Or like finalize, if it is void, that's fine. It's weird, but fine. Examples to not flag. Object clone. string clone because it's covariant with object. Oh, it's only a warning. That's interesting. It's not an error, it's a warning. Because it can be used with a lambda. Okay, weird. But sure. Okay, I'm curious about string clone though. Why is string clone allowed? String clone is allowed because... One second. String clone is allowed because it's not a signature clash. Object.clone is effectively that a class implementing an interface method can satisfy both contracts with one method. Narrowing the return time from object to string is legal. Since string is a subtype of objects. What would not be allowed is a return type that is not compatible with objects, like double or int. Oh, I see. Okay, I see. So it doesn't need to return object. It just needs to return basically something that is a super of object. So like, well, not super, but something that extends object. So like, let me ask it this. So would double clone be valid, but double clone, let's do it like this so it actually knows not to be. See what it says. Yeah, okay, that's what I thought. Okay, so as long as it's something that extends object, that's fine. So basically as long as it's not primitive, like, yeah, and as soon as it becomes a primitive, then that's the problem. Okay, we can do this then. So let me ask it as well, actually. What should I call this inspection? And then let's open up the... now I've got to find them because I can never friggin' find them. They are in... they're in diagnostics inspections. There we go. So it says I should call it... okay, it doesn't really say. It says interface method clashes with method in object. So I suppose we can call it that. There's a very long name, but like the inspections generally are going to be long names. So we're going to want something like a core interface method clashes with method in object inspection. Very long name, but there we go. This needs to implement Java inspection provider? Inspection rule provider, I think. Yes. Okay, we want our two methods. Hello, Wide. Welcome. Welcome to the stream. So... okay. Just read what it says. Ah, yes. Okay. Yes, I missed the important thing. So we need to create it in here. So we'll do a public static final Java semantic rule. Yeah, that's what I thought, Wide, but it's because I didn't stream yesterday. So the last time I streamed was last Sunday. Wait, did I actually stream last Sunday? I think I did. I think I streamed last Sunday. Let's call this interface method clashes with object method. There we go. Interface method clashes with method in java.lang.object. I think I did stream last Sunday. Let me check actually, because I'm not sure. I'd be surprised if I didn't. No, I did. I did stream last Sunday. Okay, so that's done. Okay, let me open one of these because otherwise I'm gonna get lost. So yeah, let me open, like, doesn't really matter which one, like this one, sure. I'm gonna put that on my other monitor because I need to see like how the IDE is formatted and stuff. So we got a string ID. Yeah, I mean Codex will kind of sort that out for me. List of list of Java inspection rules is equal list.of, and then we can just return ID and we can return rules, and then we need to make our method. So this will be a private static void report interface method clashes with objects, and I assume that is the correct signature. Yeah, it is. Okay, and then we can create our rule in here. So we can do a new simple Java inspection rule. We can do Java semantic rules dot id default severity message template core interface method clash, sure, and then our method. So let's just see, it's giving me like a okay, so we want to start by grabbing all the interfaces, I think is the best way. Well, we can grab the interfaces, or we can grab all the methods and then maybe get the... Probably a better way to do it, isn't it? Is it? I mean, we could traverse, right? So we could do context.traverse node, and then if node kind equals what is the kind? Syntax kind. Okay, so if we set that, say that's equal to Java syntax kinds dot interface declaration. I think it needs to really be dot id. Then what we can do if we do like more, so that just does for method declaration in node.children of. Is that a thing? Node.children? No, I mean we can do node.children, but like no, not really. Can we do actually context dot? I mean, we can get direct child, but that doesn't really get us direct. We really want like direct children. Can we not get? And we could just do node.children.for and then just say if like child.id is a method declaration, which would like technically work. Let me try and I feel like there's a better way to do this that I'm missing. Okay, actually, Codex suggests that I don't do it like this. It says that really I should be putting this in here. Which does make more sense, admittedly, doesn't it? So, actually, we're going to do that. So let's just get rid of this. And let's put it in here. I think that does admittedly make a little bit more sense. So we'll do something like that. And then we'll create our method. And then what that allows us to do is we can now use some of the methods that exist in here. So, for example, we have local type declaration nodes, right? So that's one of the things we can use. Can I import these? Is there a reason they're like that? Fine. I don't know why it wouldn't let me do that before. Interesting. Yeah. So I think that's the best way to do it. So if we then say like what does this take in? That just takes in the context. Okay, and that just traverses to see if it's one of these. Okay, that's fine. So what we can do is we can say local type declaration nodes of context dot for, and that will give us like a declaration node. And then from there, we can check the kind. So we can do if not Java interface declaration equals that, then we can continue. Then we can get the symbol. And then, you know, if declared is null, continue. And then... Okay, wait. I almost lost the friggin' inspection I'm basing this off of. Not been great. So if declared is equal null, blah blah blah, then we want to get the name of it. So we can do string owner qualified name. If that's null, we continue. Then we can do context dot declared method descriptors, and we can pass in the name. And then for methods, and then we can check if it's static or it's private, right? Because if it's static or private, then we don't care, because we only need to care if it's public. So if modifier dot is static, method dot modifiers, or modifier dot is private, f dot modifiers, then we continue. I'll stop my parentheses there. And then if it does not have empty parameter types, we can also just continue, right? Because in that case, it's fine for it to exist. So if method.parametertypes.is empty, and then just we'll say if it's not empty, then we can continue. Then we need to know if it's clone or not. So if clone dot equals method dot name, then we can handle the clone. So if like not is clone compatible with object clone, then we can report that, and then just continue, because at that point we already know the method name is clone, so we don't care about checking if it's finalized. There's no need to do that. So then we basically do the exact same thing for continue, so or for finalize, I mean. So if finalize, then we do finalize. Okay, then let's create our is clone compatible shenanigans. So I'll just do that down here. Private static boolean. Okay, we'll get rid of this. Water bottle is in the way. Let's try and find somewhere where it's not in the way. Okay. So I think we'll start by, so we have the method, we can get the return type, right, from here. So we can do return type, which is the return type. And then, yeah, basically that, but like not quite that. So we can do, if return type is not declared, then return false. Question, do we have like a... We do. Okay, so we can check if the type is a subtype of object. So we can say if not context.is subtype, and then that would be like return type display name and java.lang.object. So if it's not a subtype of object, and it's not object itself, because if it's object itself, then of course, you know, that would be silly, right? So not java.lang.object.equals display name, then we return false, and then we need to get the method return, the method throws, I think. So do we have like a throw? We do. So for thrown type in method thrown types, if the do we have a checked exception? We do. So if it's a checked exception, or if it's not a checked exception, I mean, then we do that. If it's not, is this right? So if it's not clone not supported, or it's not a subtype of clone not supported. Yeah, that makes sense. Then we return false. And otherwise, we just return true. I think that's basically it. And then we just need to do the exact same thing for finalize, which is going to be, like, simpler, to be honest. Just take that one. Put it down here. And then we'll do a kind of similar thing. So if method.returnType.kind is not equal type.kind.void, then return false. And then, yeah, basically do the exact same thing. So, I think it's just like if it's not throwable. Like, do we need to do all of this? Can't we just do this? I think we need to overcomplicate it. I think that's fine. And then just return true. So, I mean, this one doesn't even need the context, really, does it? And I mean, we can do this for other methods as well. But, like, there isn't much point. Like, we could do that for equals if we really wanted to, but, like, why, you know? We could probably else if this and then just get rid of this continue statement as well. That kind of cleans that up a little bit, right? I think that's basically it. We do need to register this, which we do in here, I think. Yeah, so we just need to make the inspection in here, but we don't need to do that because we can just use that inheritance inspection. Inheritance inspection, this one. So, like, we actually don't need to do that. Yeah, and that's already used, so that's fine then. Okay, well, that's that one done then. Clean this up whilst we're here. Might as well. Okay. Yeah, that's fine then. So then we can move on to the next one that we can do. So next one then, I guess, so let's tick that off first of all. Actually, let me quickly ask Codex to write a test for that. Can you write a test for this inspection? And then we'll tick that off. So which one was it? Let's scroll up. So it was in abstraction issues, right? Yeah, this one. So that is ticked off. And honestly, I'm going to commit as we do each inspection, I think. Okay, it's just like giving me the test. To actually make the changes. Because it's not doing that. Yeah, okay. Oh, it says we missed some parentheses. Oh, here. Okay. Sure. I guess. Wait, is that right? Are we missing parentheses there? Yeah, I suppose. Okay. That's fine. Okay, it's gone ahead and wrote the tests. It's gonna try and run them, but I don't think it'll succeed. Because it just can't for some reason. And then, yeah, I'm gonna commit this. I guess I should just wait for it to run. And you know what, we can run it ourselves and then we'll know if it works or not. So if we just do that. Hopefully it shouldn't take too long. Should be a pretty simple test. I actually failed. Interesting. Oh, but these are the ones that failed before. I can run railroad test because I know this one works. Running the actual file for some reason doesn't work. I don't know why. It just says it fails when it's fine. So that's fine. Okay, so the next one we can do, I mean, we can try and do this one. Okay, the test completed. Yeah, nice. 177 tests passed. So that's good. So I will commit that. Okay, commit. I'm not going to push. I'll push when we're done at the end of the stream. Okay, so waiting for it to finish telling me how this one works. So it says you wrote a cast to a subtype, but everything you do afterwards would still work if you had a cast to a weaker super type or interface. So okay, so the example it's given me here, just trying to find a file we can do this in. Hello? Excuse me? It literally builds like a... Excuse me? Is it the evaluator? No, that shouldn't matter because it just does that anyway. What is going on here? So it requires the ID, a severity, a message, a set of string, and an evaluator, which switches on the ID and returns these, which all just take in a context and a reporter. I think IntelliJ is just going crazy, guys. I don't think there's anything we can do about that one. I mean, it compiles, so like I don't know what to say. Yeah, I mean, we can see if I do a build, it will compile. Yeah, so I don't know what that's about, but it's fine. So, okay, it says, let's open here then, whatever. So it's saying if we do something like, if we have a list of, I don't know, string list, right? It is saying if we do something like array list of string to list dot size, right? It's basically saying that. So it's saying that casting may be removed by changing type of list to array list of string. Casting list to array list of string is redundant, right? So that's basically what it's saying. I don't know which it's. I think it's this one. No, that's just result is ignored. Basically this one, I think. Casting list to array list of string is redundant, right? So that's the one we're trying to do. So it says so what it requires is more than just checking whether a cast is legal. You need to infer the weakest type that still supports the operations actually performed on the cast expression. So find the cast expression nodes, get the target type, get the inner expression type, and then the parent usage of the cast expression. I think the hard part then is the usage, right? Yeah, this one might be a bit too difficult. At least for now, with what we have. Let's get rid of that. So apparently, like, if I did like trim to size, I didn't even know trim to size was a thing. That's interesting. I mean, we can give it a go, I suppose, right? Should we give it a go? I think let's give it a go. Why not? We might have to give up, but I think we can try. So, I mean, first of all, let's create the thing in here. So, Java semantic rule, and we will call this overly strong type cast. No, that's a silly message. Like what? This can just be cast to percentage s is stronger than necessary, and then we can say something like percentage s is sufficient, or something like that, right? And then let's create a provider. So let's go into inspection, let's create a new class, and let's call this core overly strong type cast inspection. And we will implement a Java inspection rule provider. We'll have our ID, ID, and yeah, here's where we'll do all our code, and let's just fix all of these things that Copilot's done. Fix all, there you go. This, okay, I don't know why it's done it like that. That's also not right. Like, what the hell is this? This just needs to be overly strong typecast. This needs to be overly strong typecast.id. This needs to be overly strong typecast.message template. Okay. That's our inspection. Let's quickly go ahead and add this to the registries as well. Like that. Like that. And we just need to add it down here as well. Doesn't like something here. The comma. Okay. Nice. So what's even a good way to start? So I mean, we want to find the cast expressions first, right? That's probably the best way to like begin, is to find all of the cast expressions. So that's pretty easy because, yeah, as it says, we can just basically do this. So context dot nodes of kind, and then we can do Java syntax kinds dot cast expression dot id, and we can do for cast node. And then let's start by getting the type of the cast. So let's do syntax node cast type node will be the context.direct child of cast node, and Java syntax kinds dot type reference, right? And then if that's null, just continue. Then let's get the name. So we'll get the qualified name with that basically. So cast type name is equal to context dot resolve qualified type name, which will just take in the cast type node. That's null. Or it's blank we want, or cast type name dot is blank. There you go. Then let's do syntax node parent is equal cast node dot parent dot or else null, and then we'll once again do our null check like that. And then we want to know like what the parent is. So okay, we want to first of all see if it's a method invocation, right? So if Java syntax kinds dot method invocation dot id dot equals parent.kind.id, then we'll call some kind of like report overly strong receiver asked for method, just call it method call. Well, should we do invocation? Sure, why not? Method invocation, that's context reporter cast node cast type name. Possibly, but we might want the parent as well. But apart from that, I would say probably. And then the other case is if it's a field access, right? Because on a cast, like after you're casting something, you're either calling a method or accessing a field, right? That's it. In any other case, we just don't care. So, and the only other case really is if it's an assignment to that casted thing, but that's fine. Maybe we can deal with that later if we want to. For field access, yeah, that's fine. Okay, So then what we can do is, what are inspections? Inspections wide are basically, yes, things that produce errors. So like this, for example, IntelliJ saying cannot resolve method, that's an inspection. And then obviously IntelliJ lets you do these actions on it. We don't have those yet. But yeah, basically errors and warnings that IntelliJ will show you. So for example, like if I do int a, IntelliJ will have the inspection variable a is never used, right? If I do int a is equals 0, it will probably still say that. Yeah, but then if I did like a, I'm trying to think of a way to a is equal a plus 0, IntelliJ should tell me the result of a is always 0, right? And then it will say it has another inspection that says a plus 0 can be replaced with a. So like those are all inspections. Let's create this method. There we go. Sure, those names will be fine, I think. Let's just put this one below that one so it's like easier to read. So you got like 500 million of these. Yeah, there's a lot. I can show you here's the to-do file wide. Right, so these are all of them. And these are just the like Java specific ones. So obviously we're going to have a lot more because we need to have this for modding as well. So there's going to be tons more for modding specific ones. And they're all categorized. So you've got starter ones, you've got easy ones, medium ones, and hard ones. The starter ones and easy ones are genuinely easy. Medium and hard ones are what we're doing today because I don't want to steal all the easy and starter ones. Hello Alex, welcome to the stream. But yeah, right now we're just doing overly strong typecast, so that's considered a medium one. Maybe we'll do feature envy after this one because that's a hard one. Or we could do this one, actually. We could do public method not exposed in interface. And public class methods that are not represented in an interface. We could do that, actually. That wouldn't be too hard to do. That's considered hard, or at least Codex considered it to be hard. Unless I'm missing something, I don't think that's actually that hard. But we'll see. But okay. So, for method invocations, what do we actually need to do here? So, I mean, we want to get the... I think, what do we want to do? I mean, we want to get the selector node, I think. So, I think we already have a method. That's the good thing about this. We already have methods, because obviously a lot of these can share the methods, which helps a lot. Question, would it be cool? We've got cast node and then we've got parent. I actually don't really want to call that parent. I'm going to call that invocation node. I'm going to do the same here. And we'll do that on the invocation node, which gets us a syntax node. And then if that's null, I mean, we can just return. Like, there isn't anything we need to do there. Because that will just continue to the next one anyway. So that's fine. And then we can get the method name. So string method name is equal context.name is not a thing. I don't know why you're trying to do that. We can just do syntax node dot text, I think. Is that not a thing? I mean, first of all, I guess let's rename syntax node. Let's call it select node. I mean, context.name is not a thing, but we can get like a simple type name. Or we can get the qualified type name is probably the way to do that. Yeah. And then if that's null or blank, we just return. And then we just want to get the arguments. Because basically we need to be able to know what the method is. Like, we need to get the details about the method so that we can compare it to the other methods. So we want to get the arguments next. So we want to do ints. Because we want to get the argument list, don't we? So we want to do context.directChild of the invocation node. And we want to do, yeah, argument list. So Java syntax argument list. And then make that a variable. So that's the arguments list. And then if that's not null, then we do want an argument count, because then we can just do argument count is equal context.direct expression children dot size, which basically gets all the children that are expressions, right? I believe. Yeah, basically. Which would be all the parameters, right? Or all the arguments, I should say. Not parameters, arguments. Okay, and then we just want to get the weaker type. So weaker type is equal find... We're going to have to create this method, by the way. Find weaker type declaring method. Context. Pass type name. Method name. Argument count. If weaker type is equal null, return. And then we'll just do our report like that. We can probably want to get the simple name like that, and then we'll do here context.simple name, weaker type like that. Yeah, and then we just need to make this method. So this is obviously the hard method, realistically. This just needs to be 0, by the way. Later down the line, we might need to make this actually like resolve the types themselves, but we'll come back to that later. Let's do field access first. I think it's going to be exactly the same. Or at least pretty much exactly the same. So the main difference, of course, is that like we just don't have arguments. This won't be the method name. This will just be the field name. How do you read like the toolbar at the top of the screen? What do you mean? Like this up here? Like all of these? Oh, re-add it. Oh, I see. It's always there, no? I think if you put your mouse up here, it comes. Like even if you've hidden it. Oh, what do you mean? What do you mean, like this toolbar? Which toolbar do you mean, right? I think, can you, non file edit view? It is a thing. Tool window bars, maybe? Nope. No, I know what you're on about now. Is it there? Yeah, it's that, right. It's this main menu option. I have it show above main tool. You can merge it, apparently. Oh, interesting. Interesting. I actually kind of don't hate that. I actually kind of like that. Do I keep that? I might keep that. Then I have more vertical space. I'm keeping that. Actually, I like that more. Why is that there though? Okay, I feel like that should be over here, but whatever, that's fine. Okay. This will be the same. This will just be field. Like that. If that's null, return, and then... yeah, that's it. So then I just need to make these two methods, right? I don't think this should be too hard, if I'm being honest. But it could be crazy. So I guess, importantly, let's just make this nullable, because it is nullable. So we want to get the super types. Let's start by doing that, I think, rather than starting in this method. So let's just do this real quick. Like that. Okay. So let's create a private static list of string, which will be something like this, where it's super types of, sure, we can call it that, I suppose. I think we just want to do a breadth first search. Because we can get from the context, I think we have, yeah, we have direct super type names. So we can just use that, I think, to do a breadth, blah, 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 if I could speak. A breadth, okay. Breadth. How do you even say that word, bro? It's not breath, right? Like breadth? You know, I'm gonna ask Google. It's like breath first. I would just say breath first search, but I don't think that's how you meant to say it. No. Okay, it's not telling me how to say it, so I'm just gonna have to go to Google Translate and get it to say it. Breath. Okay, you kind of do pronounce the D, but like breadth. Breadth. This is a stupid word. This is a stupid word, bro. Who invented that word? And why? Regardless, we need to do that. So we need to do... we want a DQ, right? But I haven't done this in ages. Yeah, so we want the Q. which will be a new array DQ. And then, yeah, we want our visited set. And then I guess we actually want our, like, our super type set, right? Or a super type list, I guess. So it's string, super types, like that. So we'll add our type name by default, of course, because that's obviously visited. And then, yeah, while queue is not empty, we will get the current is queue dot remove first. We'll add that to the super types, and then we'll just do context dot direct super type names of the current, and just do for super type. I kind of want to do it like that, actually. I think. Yeah, let's also do that here. And let's do that here as well, because otherwise it's just a bit weird. Yeah, so for string super type, if seen, or if, what have we called it, visited? I kind of prefer seen, but like visited is fine, I guess. We can add super type, then we just do add last, and then we just return a copy of the list, right? Hey, Russian localization guy here. Been busy for some time. I'm going to translate 40 words since October. How overall progress is actually coming along pretty well. I feel like with the SST coming along now, everything is actually starting to come together a little bit. I will say you will have a lot of translations to do. Like there is a lot in the translations. I actually, speaking of, need to make these inspections translatable, because currently they're not. They're just like literal strings. Probably wouldn't even be that hard to do. I don't know why I didn't do that initially, but it's kind of I suppose it's just kind of a pain to make these all translated at the time of developing. But yeah, I need to do that at some point, so thank you for reminding me, actually. But yeah, things are coming along pretty well. So yeah. Okay, let's do this one first. I think this is going to be easy now that we have that method. Yeah, basically this. So that kind of, not really. So first of all, we want to see if super type equals our cast type, then we just continue, and then we just want to get, we want to know if that type declares the method. So if, is that a thing? No, it really should be a thing. I mean, we can do declared method descriptors, which is kind of like, and I think that's what we're going to want to do. Okay, let's make another method then. So let's create like a private static boolean declares method, Java rule context. We want string owner type name, string method name, int arguments count, like that. So then let's just do context dot declared method descriptors of that owner type name, and then for each let's just call them methods to make it nice and simple. No, not method descriptor. I literally did not type that. Thank you, IntelliJ. If the method name equals and the parameter count. So I think it's just actually parameters.size. Yeah. So that's the list of type. Ideally, we check that the two lists are actually equal, but we kind of can't do that right now. So, to check that the types of the parameters are compatible, not just the counts. And then we also want to do this for the inherited methods as well. I assume we do have, like, yeah, we have basically the exact same thing for the inherited method. So, we'll call that method again, method, and then this again. And then return false. So then what we can do is we can just say, like, if it declares that method, return the super type. Let's rename this to candid, like that, and then that just returns null. Nice. And then we just need to do the exact same thing for fields, which, I mean, should be basically the same. So we'll do for string candidate, and then we can do here declares field like that, and then that returns the candidate, and then we'll just create declares field, which will basically be exactly the same. So private static boolean. Was that not a thing? Oh. Sugar. Oh dear. I see. That's why this one has been, that's why this one's hard. Because we don't have field descriptors. I'm gonna get Codex to do that one for us, because otherwise that's gonna take a while. Okay. Yeah. And meanwhile it's doing that, I'm just gonna add the tests as well. Well, no, we'll wait, actually, because we're not going to test them until it's done adding these anyways. Hopefully it doesn't take too long to do this. It should be similar-ish. I mean, the problem is, like, this is a massive class. I don't know how, if it's going to struggle here. I mean, obviously, the thing to note is that, like, a method descriptor is much more complex than a field descriptor. You know, like a field descriptor, it has a lot of these things, but it doesn't have parameters, right? It doesn't have a throws, so it should be a lot simpler in reality. Yeah, here you go. So owner, name, type, modifiers, declaration, symbol. Not that bad. Of course, field descriptor. That looks fine. Nice. That's it. I think that's it. So that wasn't too bad. I thought it was going to go a little bit more haywire than that, but no, that's okay. Just fix this whilst I'm here. Fix all. There you go. Yeah, these, I don't know why these are here. These need to be fixed as well. What are you? Any match? Yeah, that's true. Yeah, these can't be replaced, right? Because... oh no, they can. I thought they couldn't because they... oh, this one can't. Right, yeah, this one can't because there's multiple different type classes. Yeah. I mean, that's fine. You know, that's just how it is. But yeah, the rest have been fixed up a little bit. What's it doing? It's running the test, yeah, but this is gonna run forever. Like, it's never gonna finish. Because reasons, I don't know. Let's just also tell it, can you write the test for the what were we doing? I've already forgotten what we're doing. The type cast that typecast inspection I just added. Let's also stop the compile because, as I said, that's going to run forever, so there's no point in leaving it to do that. It says it can't find it, which isn't great. Why can't it find it? Stop it from running get status because it can't do that in WSL, but it will never learn that. Current implementation uses resolve qualified type name for member name. The safest test are the ones that... yeah, I think that's fine. Fine, right? Also, why is it doing this? Why did I decide to do that? Like, what? It literally used array list right there, so why not also just use it there? Like, what are we doing? Okay, well, I'm going to tell it to stop because it's not going to manage to do that. Okay, and we'll just run it ourselves. And we will wait. And then I think if this passes, that should be it. I actually didn't like that. Okay. Let's see what fails. So yeah, that's not helpful. Okay, but like, why? What is it like trying to do? Array list value dot size. Okay, I'm gonna ask Codex. Why is it failing? Oh, here we go. One likely issue in the current inspection implementation is that it uses resolve qualified type name with method div field name. What is it meant to use then? I mean, we could convert it to a syntax token and then get the text of the token. That's probably what it says it should do. First identifier like token text. Is that a thing? Is that a thing? That doesn't sound familiar, but it might be. It is. It is a thing. Interesting. What does it say to do for fields? So the exact same thing. Okay. So wait, where is that? Wait, but that's for the... No, that's for the cast type. That's fine. It's talking about here. Let's test that. Yeah, that makes sense. One test has failed still. Interesting. It's still failing. Do you know what's wrong? Okay, let's see what it says. I don't see anything wrong. We could try, I mean, we could try debugging the test, but like debugging tests is always just horrible. Most likely problem. Yeah, let's wait for it to finish because I can't read it whilst it's doing this. Good lord. Goodness gracious. Okay, let's see what it says. So most likely the problem is the check is assuming the cast node is the direct parent-child relationship around the call. But the parser usually wraps it. Right, because it would be wrapped in a parenthesized expression. That makes sense. Yes, that's true. So, yeah, the logic that... Yeah, okay. I see. Invert the logic. Iterate the methods, invocations, and field accesses. Get the explicit receiver. Unwrap the transparent wrappers. Oh, I don't really like that. I'm gonna ask it. Could I not continue up the parents until I have escaped the parenthesized calls? Coming up the trans... 1 second. We'll wait for it to finish saying what it's saying. Okay, so it says you can, that is a reasonable fix for this. In splitting is climbing up, blah blah blah. It's simpler than rewriting the whole traversal. Start the cast expression, walk up through the wrapper parent, stop when the parent is no longer just syntactic wrapping. The outer parent is a method invocation of the field access, inspect it. So blah blah blah. That said, there was one more thing you should check. Make sure the cast is actually the receiver, not just somewhere inside the invocation. For example, you want that and not that. So after finding the outer user's node, verify that this explicit receiver unwraps back to your cast. So we would have to do the unwrapping regardless. So we would have to do the unwrapping of the receiver regardless. So what do you think is the better approach then? Let's see what it says. So if you climb parents from the cast, you still have to answer, is this cast the receiver, the blah blah blah. Yeah, so the better approach is iterate the uses of invocation and field access. Okay. Okay. Should we just get it to rewrite it for us? Oh, man. I mean, that makes sense. It's just annoying, of course. Okay. So let's just get it to do it for us. So can you rewrite it to do this for me? I mean, fundamentally, a lot of the core logic is going to stay the same. Like, it's not going to get rid of any of this, I don't think. It is just, I think, going to get rid of... It's basically these two, right? Or these three, I suppose. Other methods it's going to have to rewrite. And then it'll have to add the unwrapping method as well. But, like, that's fine. But we'll watch it just to make sure it doesn't go haywire, because you know what it's like. Okay, so okay. Yeah, as I suspected, it seems to have dodged a lot of those methods, which is fine. So yeah, it calls those. Let's just do these. I mean, these are basically the same. These are all the same, right? Yeah, so the only difference really is that it does that. And that just happens in here. So yeah, as I said, the only main difference really is this method, because now instead of grabbing all of the cast expressions, we just grab all the method invocations and all the field accesses, and then we just unwrap them. Yeah, I mean, that's pretty simple. I probably could have done that, actually. It just made it sound a little bit scarier than it was, but, like, that's fine. Do we let it run? No, I'm not gonna let it run, because it's already given up. So we'll just run it ourselves. See if the test passed. Doing something. I don't know what it's doing. Doing a build, apparently. Interesting. Nice. 180 passed. So that means this one has passed. Yep, here you go. Nice. Sick. Okay. That's that one done then. Let's commit that too. I'm just going to have a quick look through to make sure everything's fine. There isn't any weirdness. I think that's all fine. That's all fine. That's all fine. Okay. Just quickly commit that. Wait for Copilot to do its thing, generating the commit name and description. Okay, and commit. Lovely. Next one then. So next one, I think let's try. I don't know. Should we try and do this one or not? Let's ask it. This one is marked as hard. Can you tell me what this inspection needs looks like to the end user, and also what the goal is and how it should work. I'm running out of usage, chat. That's not good. Oh no. It's fine. It resets in like 3 days, I think. So it should be okay. Good lord, it's writing up a storm. Okay, we're gonna have a lot to read through, huh? Okay, let's start at the top. So you made this method part of the public API of a concrete class, but it's not part of the interface API that the class is supposed to represent. Example: interface service void start, default service implements service. Oh, I see. I see. So a class that implements an interface that has a public method, basically. Okay, I see. So the inspection would flag reset cache because reset cache is a part of the public API, but it wasn't exposed by interface. So the intent is the default service is consumed via service because reset cache release. Yeah. Is this class meant to be used for an interface? If yes, so if this is not compiler error, it's a warning. Yeah, that's fine. So something like public method reset cache is not exposed through any implemented interface, or public method reset cache is not part of any of interface contract service. Probably go with the latter, but I don't know. Oh, I suppose you'd have both, kind of. Quick fix direction would be conceptual. Well, we're not worrying about quick fixes yet. We'll do those later. It's hard because it's not a logical syntax check. You need to reason which classes are actually interface backed classes, which interfaces are relevant, whether a method is inherited from a superclass or object, whether a method is intentionally public but implementation specific. Right. Whether a class is a public API class, not just an internal concrete type, possibly whether the method is used externally via the concrete class. A naive rule would produce lots of noise. Yeah, I mean, that's the problem with a rule like this, right? Is that if it's slightly wrong, then you're going to have a lot of methods getting flagged for absolutely no reason. So what correct behavior looks like? So find concrete classes, check whether they implement one or more interfaces, collect the effective interface method set from those interfaces, collect the class's public instance method, each public instance method on the class, ignore object methods, ignore methods already present in the interface set, and then flag any methods that remain. Yeah. You need to decide what counts as not exposed in an interface. If a class implements multiple interfaces, should a method be okay if it appears in at least one? If directly implemented interface or inherited ones too, usually include inherited interface methods too. So that superclass method, superclass defines a public method known in the interface. Should the subclass be blamed? Usually no. I would agree. I think that makes sense. Many concrete classes intentionally have extra public methods. If you flag all of them, the inspection becomes noisy. Yeah, I don't know about this inspection. I feel like it's kind of silly. Like, does IntelliJ actually have this? Like, it doesn't, unless it's disabled by default. If a class implements serializable or comparable, does that not mean every public method must be in the interface? That does not mean every public method must be in the interface contract. Yeah. When you inspect concrete classes that implement one or more non-marker interface, only look at methods directly declared in the class. Only consider public non-static methods. Ignore methods matching interfaces. Ignore object methods. Report the remaining methods. Okay. I feel like we can do that. Right, guys? Like, I don't... It can't be that hard. It can't be that hard. Let's look at this. And let's try and... Let's give it a go. Might as well give it a go. Let me just mark off this. I should have done that before I made the commit, actually. Let me amend the commit real quick. Here we go. Amend commit. And then amend last commit. There you go. Okay. Nice. So that's included in the last commit now. Okay, so let's start by creating the rule. So let's go into rules. Okay, and let's create. So Java semantic rule. What do we want to call it? Public method not exposed in interface, I suppose, is just the way to go, right? So public method not exposed by interface. Sure. Public method percentage s is not exposed by any interface implementing its containing class. Yeah. I think it's not exposed by, no, let's call it, let's say it's not exposed through any implemented interface. Like that. Okay, and then let's create our inspection. So new class, let's do a core public method. Wait, what did we just call the rule? Public method not exposed by interface. Okay. So we can call it a core public method not exposed by interface inspection. Implement Java inspection rule provider. Let's do our ID. Okay, let's fix all of these. Nice. This should be ID like that. And then we have our method there like that. Now really, I mean, this should be up here. This should be like list of Java inspection rules is equal that, and then just return rules. Not super important, but like I like to do that, so I'm gonna do that. So okay, I think best way to start then is let's how do we do this? I mean, do we want to ignore classes that extend other classes? I'm gonna ask it. Okay. Okay, yeah, for now we'll just ignore classes that extend other classes, and maybe later we'll come back to that. But I think for now that's fine. So, okay, let's just start with classes then. So let's do context dot how do we even do this? I mean, we can get the types, right? Not like this though, is that? We can do I guess we can just traverse for them, right? Or you know what? We have where is it? In here, I think we have this method. And we could just add it to here even. Can we do that actually? Let's do that. And then we'll just add it in here. Like that. And then we'll just come down below our report methods. Right, because then we can just do it pretty simply. So we can do like local type declaration nodes context dot for, which will be the declaration node. And then we want to check if it's not a class declaration, then we just continue because we only care about classes, right? Then we can get the symbol. And if the symbol is null, we continue. Then we can get the owner name like that. That's null, continue. Then we can check if it's abstract. So like if context, I think we have an, yeah, is abstract type, continue. And then we can check if it extends a class, like a some kind of class. So come down here, let's have a private static boolean extends, but we want to know if it extends a class that's not object, because obviously if it extends object, that's fine. Let's do like extends non-object super class. Java rule context and string qualified, not qualified, qualified name like that. And then we can just do context dot direct super type names of owner qualified, oh, qualified name we called it, didn't we? Which will get us the super type. And then, yeah, if it's not an interface and it's not an object. So if not context is interface type and it's not object, return true, return false. So then we can just do if that on context qualified name, then we continue. Then we can get a set of string, which will be the exposed method signatures. So that we know what methods are exposed, right? So let's make a method to do this, I think. Interface method signatures is equal exposed exposed interface method signatures on context qualified name. Okay. Put this all the way at the bottom. Do qualified name. Okay. So then let's create our set so that we once again can not have duplicates. So interface types, and then one second, let me put my phone on silent. Okay. I think we want to kind of do a breadth first search again. Yeah, we're gonna want some kind of like collect. Sure, kind of. I'm not sure that's exactly what I was looking for, but yes. So if not, no, I was just thinking. I don't like what it's called. Let's call this out. Let's call this visited. So if visited does not add qualified name, then we return. Then we go through the super types, yep, as that says. And then if it's an interface, we add it to the interface and just recall this method. So this is just adds to out, which is really like signatures. Like that. Let's just I don't really like this. Collect implemented interfaces. Like that. And then we can just call that method in here, right? And then we can do set of string, which will be the signatures. Like that. And then just for interface type, we can get all the methods and just add them in here, right? So context.declared method descriptors on interface type dot for method. Then yeah, if it's not static and it's not private, then we just add it. And then basically, yeah, the same thing for inherited methods as well. And then we can just return set.copy of signatures like that. So now in here we have our exposed method signatures. And so we can say if it's empty, first of all, then we don't care, right? Then we can do context dot method descriptors, which gets us the methods in that class, right? So we know what methods to go through. So for methods, first of all, if it's not public, we don't care, right? So if not modifier dot is public, or if it's static, sure, that's true as well. We also want to know if it's an object method, right? If it's a method from the object class, check if method is from object class, and then we do if interface method signatures contains that, then we continue because we don't care. Otherwise, we just do reporter.report the node, and then I think we have a signature key like that. So we do need this one here. So we'll have something like if is object method, then continue, right? I don't think we even need context. Maybe we do, but I don't think we do. I guess we can actually. Sure. So let's create a down here private static boolean. Yeah, so that gets all the methods in the object class, and if the signature keys match, then boom, right? I think that's it. Unless I'm forgetting something. I don't think so. So I can kind of do that here actually, because that makes that a little bit easier to read if I do that. I think that's it. I'm going to tell it to add the test for me. Can you add the tests for this inspection? Let me just really save this and make sure that's all through. We're going to add the tests. We'll run the tests. Hopefully it will work. And hopefully we'll have time to start another one. And whilst it's doing that, let's try and figure out what one we can actually do. Possibly feature envy. We could look at that maybe. If we can get both those hard ones done. We're not going to get these ones done, but we can get this one and this one done. That'd be great. Oh, there's also this one. I didn't even see this one. Class reference is one of its subclasses. Ooh, interesting. Feature envy. Yeah, I don't really know. Apparently IntelliJ has this. So apparently if you have code that like just manipulates the data of a different object, then it gives you a warning. Apparently. That's my understanding anyways. I've never come across that, but apparently it's a thing. I mean, you probably never had it because, like, that's a bad thing to do. Like, why would you ever do that, realistically? Right? I mean, there's just no reason to ever really do that, so... Okay, did the tests complete? They did, right? If we go, Can't find it now. I think it's this one, right? So if we come in here and we look for... What are we looking for? What is it called them? Court inheritance rule does not omit public method. Court inheritance rule does not omit public method. Court inheritance rule. Here you go. Yeah, those succeeded. So that's good. Okay, lovely jubbly. So we can go ahead and commit that then. Let me just once again mark that off on here. How long do you think it will take you to get through all of these? Well, that massively depends if I have help or not. If I have help, then a couple weeks. If I do not, then probably a couple months. So... yeah, that's what I would say. What one are we working on right now? Like, why can't I find it? Am I blind? I actually can't see it. Public method. Yeah, here it is. Found it. Down my chat. Took me a while, but I found it. Okay, let me commit that. I mean, do you think there'll be more stuff for me to do post uni? Certainly, yes. If people haven't done it by then, yes. I don't know how much you guys are gonna come and help me out with these, so I don't know. There are tons of them marked as easy and starter, so like, you know, just saying. Well, I did not label the difficulty. Codex did that. I was not going to go through all of these manually and do that. But I think it's probably accurate. I mean, I did check that it did make, like, reasonable assumptions. Like, and I think they're mostly correct. Like, for example, let's try and find an example that I think are mostly correct. Like, empty try block. I mean, that is as starter as it gets. It's literally just checking if a list is empty. That is it. Like, literally 2 lines of code, I think. 2? Probably 2. Well, 3, because you first of all get the try blocks. You check if they're empty, which is the if statement. And then if they're not, you report it. So 3 lines of code, which would be the same for this one as well. Here you go. Here's another starter one. Throw inside finally block. So you find all your finally blocks, and if one of the children has a throw in it, that's it. Simple dimple. Continue or break inside finally. Yeah, once again, I mean, simple, right? Negatively named Boolean variable. So flag's Boolean name is called disabled or not something. I mean, once again, that's pretty easy. Nested switch statements. So look for switch statements that are inside switch statements. I mean, that's easy as well. A little bit of recursion, but like, you know, not hard. Negated equality expression. Oh yeah. So if you have like if not A is not equal B, right? That would be a negated equality expression because this is redundant, right? Because this is a not. So you would just do, you know, that. That kind of thing. So yeah, that's nice and easy. And if you go like hard ones, the hard ones are generally pretty hard. I would agree with the hard ones. Like, let's see, let's find a hard one. Boolean method is always inverted. Yeah, I mean, that's pretty hard because you have to find all of the calls of that method and see if they are inverted or not. Seeing if they're inverted isn't hard, but finding everything that calls a specific method isn't easy. Is there an impossible difficulty? No. Because none of them are that hard. Like, they're all very doable. Like, honestly, I reckon anyone could probably do one of the hard ones. Like, obviously it wouldn't be easy, but I reckon anyone could do it. Because they're hard, but they're all effectively the exact same thing. At the end of the day, all you're doing is just looking at, like, the children or the parents. You're just traversing. You're either traversing up or you're traversing down. That is basically it. So, like, even these ones, like, class may extend a commonly used base class. Okay, this one is, like, kind of actually really hard. Suggest better known basic straps. Yeah, I mean, that's probably one of the hardest ones on here, actually, to be fair. Because that's, like some of these are like, what you would consider intelligent inspections, because, like, yeah, like, that requires knowing a lot of information. Final declaration cannot be overridden at runtime. Detect final members that break framework subclassing / proxy expectations. I don't really know what that means. Oh, okay. Right. I see. So if you're writing like a proxy or something, you wouldn't be able to have final methods because they need to be overridden at runtime. Right. Yeah, that would be pretty hard as well. Because that requires you figuring out that the class is a subclass or a proxy. Right. Okay. Something like this is super easy as well. As it says. I mean, I genuinely do agree with most of these as what it's rated them as. Like detecting if an interface is only used to inherit constants. Pretty easy to do. You just grab the interface, you see what's inside it, If it's only static constants, then you say, hey, that's not okay. That is that is it. Type parameter extends final class. Like generic bounds that cannot vary beyond a final type. Type parameter extends final class. Yeah, that makes sense. So if you were doing like T extends string, for example, that would give you a warning because string is a final class, right? So that's pretty easy because you just check if whatever this is a final class or not. So that's literally just an if statement. The hard part here is actually just finding string, but certainly doable. I mean, yeah. Honestly, the hard part about all of these inspections is you have to kind of understand how Java works, and like more specifically how it's structured. Like you have to understand that public, static, and final are completely different things. Like this is something, this is something, this is something. These are all inside of something. So these are all something. And then this is something. And this is something. And then this all together is something. And then this is something. This is all something. You know, this is something. This is something. This is something. Etc. That's kind of what you have to understand. I think once you got that down, like generally they're all pretty easy to do. Anyways, what's the next one we can do? So we have like 20, we have like half an hour ish. I'm sure we can do another one in half an hour. We just have to find the right one to do. We do something just completely random. Just find a completely random one. I wish they were numbered, and then I could just ask like ChatGPT, just like pick me a random number between something and something, but they're not numbered, so we can't really do that. Yeah, but the line numbers aren't gonna work, bro, because half of them are friggin' like this, or like just blank lines, or they might be a new line where one of them's like that, or they might be something down here. They might be the section headers. Like, it's not really gonna work. Keep randomizing. You know what? Fine. Let's do it. Okay. Actually, I'll do this in stream browser. 1 second. Okay, here we go. Random number generator. Okay, why doesn't that bring up the freaking Google one, bro? Okay. So we want between 1 and 647. 647. Generate. 399. Let's have a look what 399 is. So 399 is, oh no. Okay, this is actually the hardest one. Like, I'm not even joking. This is the hardest one on here. We're not doing it. We're not doing it because I can't. Like, this is genuinely the hardest one on the entire thing. Because, like, yeah, like, that's not happening. You gotta do it eventually. Yeah, but, like, it's not important. We'll just generate another one. 60, there's no point in me even looking because I know that's already one I've done. 581, that... yeah, it's also not going to take 20 minutes. It'll take like 5 hours at least. 581, let's have a look at 581, but I think that might be 581. Cast conflicts with instance of. Detect cast incompatible with an earlier type test. Ooh, that's a hard one. That's labeled as medium, but I actually don't think I agree with that. Well, I'm just trying to think how you even do that. So you'd have to like track the types. Or no. I suppose you don't have to track the types. You just have to know. Okay, yeah, I see. So if you've done an instance of something, then you have to see like. Okay, yeah, I see. But that's kind of I fully understand why it's labeled it as medium, because it's not hard, it's just annoying. Well, I will say to you guys, all of the medium ones are not hard, they are just annoying. Like all of them. They're annoying and awkward to do. I mean, I kind of know how I would do it. It's just kind of a pain in the butt. I'm gonna get Codex to do what I did last time and give me like a just talk me through it. Yeah, okay. Let me do this. And there you go. Okay. See what it says. Okay, I think I already know how it works, so there wasn't really much point me saying that, but yeah, you basically have to track the instance ofs of a variable, right? So I mean that wouldn't be too hard, because you could just have like a set of known types, and every time you do an instance of, you add that type to the set. That's effectively what you would do. And you just do that for every single variable. Would be the way to go. The hard part is like traversing, because you have to traverse the code flow. But yeah. So let's see what it says. You already tested the value of instance of, but then you cast it to something inconsistent with that test. So if object is an instance of string, and then you cast it to an integer. Yeah, that's basically what I thought it was. Because obviously that doesn't make any sense. So cast the integer conflicts with preceding instance of. Yeah, let's see what IntelliJ actually says here. Right, so if I have like, okay, for example, I have a list of, you know, let's find instance of. The thing is, usually when I instance of, I pattern match it. So it's not very often I do an instance of without pattern matching. So I'm not going to. I might struggle a little bit to find something. But okay, sure. You know, let's just write something. So let's do object A is equal. Just do object A, right? If we say if A is instance of string, then we can do. We should do this actually. Int A is equal null. If A is an instance of string, and then we do like. Oh, object A, I mean, I don't know why I'm saying int. Now I do integer B is equal integer A. That should give us a warning. No, see, that's just saying it's a class cast exception. See, IntelliJ isn't giving me a warning, which is interesting. Interesting. I'm surprised. Maybe because they're not of the same type. What if I did, what if I did it like this? What if I did number A is equal 1, and then I said A is instance of integer, and then I said, like, float B is equal float of A. Then it should say... See, it just says there's a class cast exception. Oh, I guess that's right. I guess that is what it should say, right? Yeah, I guess that is the warning, right? But yeah, that is the warning. Okay, I see. Okay. Da 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 da. Ooh, see, that's the hard part. Yeah, and while loops as well. The second case is important. Instance of a superflag does not. Yeah, true. The inspection only fires when the cast is incompatible. So past establishes the cast of B is only suspicious when B is not compatible with A. Because it's path sensitive, not locally path. Oh, only locally path sensitive. Yeah. Which expression was tested by instance of. If the cast is on the same expression, whether the cast happens in the branch where the test is known, true or false, whether the cast type is compatible. So find instance of, record the tested expression, the tested type, and whether the current branch implies the test is true or false. Yeah. I don't think we're gonna have time to do this, guys, because it's an annoying one. Okay. Let me close that. Okay, let's get rid of this first of all, because obviously we don't want that. Okay, yeah, we'll do if statements first, because I mean, if statements obviously make it a little bit easier, while loops a bit more complicated, for loops complicated. So if we just do like so I mean, first of all, let's create the rule, right? So yeah, that's fine. So let's do Java semantic rule. So like, what are we calling the rule here? What was the name? Cast conflict thing with instance of. Yeah, I would agree. I think that's a decent name. So then we'll create a new inspection. We'll call this Java cast conflicting with instance of inspection. Inspect. function. Then we're going to have our ID. Then we're going to have our list of Java semantic rules is equal list dot of. We'll deal with that in a second. We need to implement Java blah blah rule provider. There you go. ID and rules. Can't wait to see the package of like 1,000 inspections. Yeah, it's gonna it is gonna be kind of crazy. We are gonna literally have like 1,000 inspections. I mean, to be fair, well, actually, these are, yeah. So I mean, these are all just like the core ones, but we'll need to move these into a package which will be like Java ones. Like I've actually kind of named this wrong. This should be 4. But I'm gonna need to rename these to like Java blah 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 rather than core. I should probably do that sooner rather than later, actually. I'll do that after this, actually, because that is quite important. Yeah, like there's gonna be a lot, because we're gonna have this same kind of thing with all the other languages that we implement in the end. So, you know, JSON, TOML, whatever. Okay, there you go. Okay, and then, yeah, report that. Create that method in there. Which will be the reporter. Boom, boom. Put that down here. Okay. So, yeah, let's start by just like finding the if statement. So I think that's probably a good way to start. So let's do context.nodes of kind. Let's do Java syntax kind.if statement.id, and then just do .var, and this not .var, let's do .for. So this will be the if node, right? Then let's grab the condition. Condition is equal. Can we do direct expression child? I think so. Oh, but that finds the first expression children. I mean, first direct expression child. Can I not just do that? I think so. Yeah, I think so. We don't need to do an or else though. Okay, so that gets us the condition. We need to check, of course, if the condition is null. So if condition is null, continue. Then we need to get the instance of... Now, do we have a fact class? We do not, but we're going to need one, which would be the fact. I suppose let's just create this class now. Sure. Private record instance of fact, which will take in the string variable name and a string tested type name. Okay. So now we can get that. Okay, so we basically want to, yeah, but we want to extract the positive one. So if it's negative, we can just invert it and get the what we know is positive, basically. I suppose let's create this method now as well. So let's do private static at nullable instance of fact. Okay. So what do we need to do in here? So first of all, if it's not an instance of expression, we don't care. So if not Java syntax kinds dot instance of expression dot id dot equals condition dot kind id. So if it's not an instance of, we don't care. Then let's get the children. So list of syntax node expressions is equal to context dot direct expression children condition. If expressions is empty, just return null. Then we want to get the actual one we care about, which is just the first expression, right? So tested expression. Sure, but we can just do get first. And we need to see if that's not a name, because if that's not a name, Java syntax kind dot name, then we return null. We're not going to have time to do this today, by the way, guys. We're going to end up halfway through, I can already tell. String variable name is context. We have a like first identifier thing. Yeah, that one. That one. And then if that's null or it's blank, return null. Then we can get the type reference that basically this is for. So we have the name, then we get the type reference, which we'll type node. That's direct. No, it's just direct child, right? And then I can do Java syntax kinds dot type reference dot id. If that's null, return null. Then we get the string tested type name is equal context dot resolve. No, context. Resolve qualified type name. If that's null or blank, then we return null. And then finally we can return our fact. Nice. So once we have the fact, we can check if the fact is null or not. Okay, then we can get the then branch of the if. So if statements, by the way, for those who are not aware, are so like if you have like an if, you know, blah blah blah, and then you have an else if, you know, df, and then you have an else. This is actually like two if statements. So it's if else. No, it's wait, it's how does it work again? So it's if this, and then it's you have the else statement, which is this. Then you have an if this, and then you have an else, which is inside of this else. Is like how it works. It's kind of confusing, but that's how Java does it. So the then branch, it's only an if then. It's not like an if else, if else, if else, if else. It's just an if then, and then inside the then branch you'd have the nested if else, and then you'd have blah blah blah. So we need to get the then branch, which I don't think is as easy as just like calling a method. So we'll say like then branch of or something. So we might as well create that now. Private static at nullable syntax node. So we got list of syntax node, which are the children. And then boolean seen condition. Yeah, so we need to know if we've seen the condition or not. Then we do children.for. We can get the kind. If we've not seen the condition and it's an expression, then we have seen the condition and we continue. And then we don't do this. We just do if seen condition, then return the child. Otherwise we just return null. And then we can have an is expression kind. Question, do we have a... I don't think, do we have that in the context or not? Context dot. We have is expression node. So I mean we could just do context dot is expression node child. And then just pass in Java rule context. Like that. That's probably a better way to do that. Because I assume that just does what we want anyways, right? Yeah, pretty much. So that's fine. As a long class name, it is pretty long, but not that long. I don't think it's the longest. I think it's about on par with this one. Yeah, not far off. Okay, so that gives us the then branch. So then we want to find all the casts, right? So yeah, basically that, I think. But like we want to do that recursively, so we'll have to make a method to do that. Private static list of syntax node. Find descendant cast expressions. And this just needs to take... Well, I suppose we can have a collect method, can't we? Let's just have a list of syntax node. Casts is equal to a new array list. Then just have a collect descendant cast expressions, which takes that in, and then just return list.copy of casts like that. Then we'll just have a method that basically just does that. Hello, Weeple the Second. Welcome to the stream. This can just be... I think this can just be node.children. I don't think that needs to be anything weird like that. So like, yeah, this doesn't need to be passed in there. And we'll take it out of there as well. So then that finds us the cast expressions. So we do find descendant cast expressions on then branch dot for. This will be the cast node. And then So we want to know if it casts to the same thing, right? So like, let's have a private static boolean casts same, yeah, variable, sure. That takes into context, then I can take in the syntax node, which is the cast node, and then I can take in the string variable name, and then we can just do in here cast node dot children dot for child. Check if it's a type reference. So if Java syntax kinds dot type reference dot id dot equals child dot kind dot id, then we continue. Is that right? I think so. And then if not, context is expression node, then we continue, and then we can get the expression, which is gonna have to unwrap that. If that's null, or it's not a name expression, yeah. And then, why am I continuing? I don't want to continue. I don't want to continue that. I want to return false. Welcome back. And then we want a string. Oh wait, do I already have that method? I do. Or overly strong typed cast expression. Or overly strong typed cast expression. I will take it. I'll make it public. I mean, I could probably move these into the context. Let's do that actually. So let's just take these methods. Let's go refactor. Let's move members. Move class. No? Refactor. Move members. There you go. And I want to move these to Java full context. Okay. Where are those being called? Because I don't actually want to call them statically. I just want to call context. Not done that. So like you, I do want to be static. And I don't want you to be static either. They definitely shouldn't be at the top though. Let's put them somewhere reasonable, shall we? Like down here somewhere. Want them kind of above all of these. So these are all private methods. Find our public ones. Okay, here. Put them here. Yeah, they'll be fine there. Do they need... No, that's fine, okay. Yeah, this should just be context as well. Okay, and then this will just be context.unwrap, like that. And then we have the casted name is equal to context.find first identifier. That one. On expression, and then just return equals casted name. return false. And I think that should basically give us what we want. I believe. So in here, we can then say, if it does not cast the same variable, then we just continue. And then class type name resolve qualified. No, we just want to do syntax node. Cast type node. Yeah, so that gets us the type reference. If that's null, we continue. Then we can get the name, which resolves the name, and the name is null or blank. We continue, and then we need to know if the type's conflict or not. So yeah, obviously we'll do that in a second. What is an inspection? An inspection is like IntelliJ here saying continues unnecessary as the last statement in a loop. That's an inspection, for example. So in the template projects, do you have multi-loader? Currently, we don't have any templates. Or, well, we kind of do, but like not really. Like they're very temporary. It's not like the final templates that we're gonna have. But to answer your question, no, we do not. Multi-loader is not gonna be we're not going to deal with multi-loader yet because it requires too much complex Gradle shenanigans. So we'll do that in the future. Okay, we want to know if the type's conflict then. So let's create a private static boolean types conflict. So we need the Java rule context, then we need the instance of type, and we need the cast type. So if the instance of type equals the cast type, then return false because they don't conflict. If the cast type is a subtype of the instance of, then they don't conflict, right? So hopefully, yeah, is subtype cast type instance of type, I think is the right way around. Then that's fine. And if that's the other way around as well, so if the instance of is a subtype, then that's fine. Otherwise they conflict, right? Now that's going to tell us this, but I am going to say the press for statement and just say, yeah, want to be explicit about logic. Exactly. Yeah, so then we can just go ahead and say, if these types conflict, right? Now, yeah, that's fine. Then we can just do reporter dot report cast node, and then context dot simple type name, and then context dot tested type name, right? No, oh, it's because of the comma. That's why. Okay. Oh no. Okay. And then we just need to make this inspection. I think that's it, unless I've missed something, which is actually like extremely likely that I've missed something. But I mean, we'll see in a second, right? We'll get Codex to generate the test for us. Let's just add it in here first, though. How would you test all of these? Well, I can either go into the IDE and do it, or I can do what I'm currently doing and I just have Codex generate a unit test for them. So like if I go into the test package, come in here, not that one. in here, I think. Wait, no, it's not in there. It is in here. Wait, no, where is it? No, it is in here. Is it not in here? It's in here, right? No. Diagnostics. Oh, yes, you're right, Wade. I've never wrote one of these tests myself. Codex always writes them for me because I hate writing unit tests, bro. But basically, it just runs the inspection. So it calls run provider. So it basically just does what the IDE does. So effectively, it just friggin' analyzes the text. So this will do the lexing, this will do the parsing, then it runs the semantic analysis, then it runs the inspections. That's effectively what this does. Like honestly, I could write these myself. Like you can see they're not hard to do because it's literally just run the provider, give it the code to run, which will be the broken or not, and then it will just say, okay, does this diagnostic include this this type? So repetitive though, yeah, I mean, you know, that's just unit tests for you. I mean, unit tests are always pretty repetitive. When you want to exhaustively test something, unit tests are just like, ugh, disgusting. But there isn't really a better way to do it, so obviously I could just go into the IDE and I could literally test it, because once I put it in here, then it'll work in the IDE as well. But like, that's just more effort, to be honest. Just like having to run the IDE, go into a project, create a new file, create the tests in that file. It's just not worth it. So I rather just get Codex to generate the test for me. And plus that means we have unit tests. So, you know, if something in the future comes back and breaks it, we don't have to manually go into the IDE and test every single friggin' thing, because we can just see the unit tests will pass. So, can you generate the unit tests for... That's literally all I ask it to do. Give it, you know, a minute. We'll have the unit test. We might actually finish this before 10 o'clock. That would be crazy. Bear in mind, I didn't think we would. That is presuming this works, of course. No, I try saved. Yeah, I mean, we're only handling if statements, to be clear, guys. So, it is correct with that. Yeah, okay. So we do that. It's wrote 3 tests for this by the looks of it. So it's done. If object is instance of string. Wait, no, isn't that what we had before? Isn't that a cast one? Oh, no. Wait, that is what we're doing. Oh my god, I'm losing my marbles. Yeah, that is what we're doing. So this should test kind of the default case. This should be fine, right? Because if it's a char sequence, then it can be a string. So that should be fine. Yeah, so that just asserts false, that this diagnostic has not been emitted. That's fine. And then it's also done... if it's not a string, then integer. This one, I don't know what this is going to do, because we haven't handled like if not. So let's run it and just see if it works or not. Okay, one failed. I'm guessing that's the if not instance of. Am I right? So this is this one. Oh. Interesting. That means it's not working. Did it say anything it thinks might be wrong? No. What happens if I do that? I don't know. That's I don't know. So why? This might need to be context.direct descendants, maybe. I'm just gonna tell it it's failed and see what it says. The likely problem is an extract positive instance of fact, not the test. Right now it requires the if condition node itself to be a raw instance of expression. With a normal Java syntax, the if condition is usually wrapped. Oh, okay. So we should do context to unwrap beforehand. I'm not sure that's the problem though. But sure, we'll try it. So we just come in here and we say condition is equal context.unwrap condition. If condition is null, return null. Let's see if that fixes it or not though. No, so that didn't fix it. I didn't think it would. But this is the same one though, right? Yeah. Did it say anything else could be wrong? Next patch this is then of branch. I mean, we could try and debug it. But like, as I say, debugging test is like pain in the bum. But we can try. Okay. Okay, so we're in here. Is this the right one though? Cast conflicting with instance of does not admit. Is that the right one? So that's that one, and this is cast conflicting with, so this is does not emit. So we don't care about that one then. Cast conflicting, yeah, that's the right one. We get the if node, we get the condition, okay, it's really hard to read with all the green and friggin' red nodes, but okay. We get the fact. It says the fact is null. Interesting. Probably should have done that. Let's rerun it again and see if we can get into here. Okay, so condition. Okay, so is condition an instance of? So, I mean, we can get the green, and the kind is an instance of, yes. So then we get the expressions. So there is an expression. So let's go green. Now it's a name expression. Okay, so that should be this one. So it should be a name expression. So then it should get the variable name, which is obj, which is correct. So then we get the type reference, which is saying is null. Interesting. So if I look at the condition here, condition, let's go green, and it should have a type reference. So it has a pattern, has an instance of, a white space, and a name expression. Okay, it's because it's a pattern then, right? So I suspect a pattern has a child, which is a type reference. Okay. Right. I'm gonna ask Codex what it thinks. So the issue is that doesn't work as the child is a Java underscore pattern, which inside of that has a type reference. How should I fix that? I expect it will just say grab the pattern and then get the okay, so I think I should make instance of type reference. Yeah, basically what I just said, except it's put it in some methods. So, you know, sure, we'll do that. Okay. And then it's done find first descendant, which sure. Okay, so then what it's done is type node comes instance of type reference, context condition, and then result qualified name. Okay, so let's just run it now and see if that works now. I think it should, but we'll see. And then once this works, we will end the stream there. I think that has worked, right? Yeah, nice. Fantastic. Okay, so that is going to be it for this stream. Let me quickly just commit this to GitHub. So what were we doing? Past conflicts with instance of this one, right? If complete completed. If complete. Let's just say if statement completed, like that. And then I can commit that. Okay. And then, yeah. By the way, guys, Industrial stream will be tomorrow. I didn't do it yesterday because I was too tired, and yeah. I got home late as well, but it will be tomorrow. Normal time as well. There you go. I'm going to commit that. Okay, and I'm going to push those. Okay, that's all done. So yeah, as I say, that is going to be the end of this stream. I hope you all enjoyed. I'll be live again tomorrow with some Industria, so I will see you all then. Goodbye.